Chemical equilibrium. Chemical reactions are oftentimes reversible, and why not? If A plus B can turn into C plus D, why can't C plus D turn into A plus B? Well, it oftentimes happens, and you get stuck. The reaction gives you a lousy yield because it's in a state of reversibility, where the forward rate equals the reverse rate. Don't fall into the trap of saying that the reaction is done or stopped. Just say that the rates are equal. We can define an equilibrium constant. That's some number where larger means that this value is higher. This is just a man-made attempt to quantify chemical equilibrium. It was decided by who knows to make the equilibrium constant equal to the concentration of product C over the times the concentration of product D, in each case taking those coefficients and raising them to exponents. So very sensitive to those numbers, divided by the same thing for the reactants. A and B, coefficients become exponents. If you get a low number, less than 1, it means that you have a lot of reactants still. That's considered by synthetic chemists anyhow to be a bad thing, right? The reaction didn't go very far. If it's greater than 1 or approaching infinity, things are good, and the reaction is gone to completion. We generally omit solids and liquids for this because they are not part of the system. They have precipitated out. If the system is aqueous, you look at everything that's aqueous. If the system is gas, you look at everything that's gas. So be careful when you see these things to only consider those things that are part of the system, intimately mixed. And chemical reactions don't always show that. You know, when you have a solid, that usually means that, for a product anyhow, that means that it is precipitated out of solution. General rule, omit liquids and solids. This is an introduction to chemical equilibrium.